Hello students, let's have a look at paper 2, 2022 Edexcel GCSE Computer Science. It's really important to follow the instructions here. So you've got a student coding folder, looks like this, and when you open up, what I suggest you do is you open up these files and immediately save a version of them as Q01 finished, Q02 finished, so that you've got the original file without any of your amendments to it. First of all, you're not meant to overwrite any of the original files, and also it makes it really difficult if you make a mistake to go back to see what you were given. So each question here says save your amended code as Q01 finished, uppercase, no spaces. Please do that. So let's look at question 1. We've got a global variable here. It literally tells us what to do in the coding question, but let's read. It's about ASCII. Oh, we've got a validation, so only numbers 5 to 30 are valid. Fine. Adding 60 to a number and then applying the function char, because 60 is A, isn't it? Generates the equivalent ASCII code. So if we do our code correctly, it will look like this. We can put these inputs in and it will give those outputs. That's the best way to make sure you're getting 10 marks. Tick these off as you go. So create an integer variable. That's going to be up in global variables. It says here add a line. So I'm just going to initialize a variable with an integer value of 0, as it said. That's tick number 1. Then it's line 15, complete the line to take input. So when we take input from a user, it's always a string. So what we have to make sure is we convert that into an integer. So I'll say enter a number. I always put a colon and then a little space, because people tend to put spaces in when they put answers in. Check the input numbers between 5 and 30. Well, that's what I would probably. There are different ways you could do this. I'd probably say if the number is greater than or equal to 5, and so I've got 2 conditions because I'm checking the upper bound as well. There are different ways you could write this, but you could say is less than 31, right? If it's less than 31, it's up to 30. You could say less than or equal to 30 as well. Okay, the different ways you could do this. Add 60, so decimal code equals, I know it's got 60 in our global variables, but let's just say, we're going to say decimal code, it says add 60 plus our number. Because I'm pretty sure capital A is 60 in ASCII. Complete the line to join strings together with concatenation. Concatenation is a plus. So using the plus actually joins all of these strings together. It's not like displaying it with commas or using F formatter strings. You're not meant to add any additional functionality to this anyway. So simply use the concatenation. Now, if I did a carriage return here, it tells you which place this needs to be. A common mistake might be students do this down here. They lose a mark. So make sure that you're indenting it. Do not use spacebar. So print, I always make sure the brackets and quotation marks are done first. Invalid input. Now, just make sure it's spelled exactly the same as this. Okay, exactly the same. Let's run it. Enter a number for invalid input. That's what we expect. Which, if we put 5 in, equal to 5, yeah. A 30, etc. And if we put 31 in, invalid input. Great. First question out the way. A program uses turtle graphics to draw a simple image. Circle, outside square, centered, horizontal, vertical grid lines, 400 by 400. Circle is, so diameter across. The circle is outlined gold, other lines are black. Okay, it has error, so that there'll be, here we've got lots of lines of code, but there are some errors in it, so we need to sort that out. We've got some constants, constants always written in uppercase. Now that's just the way that we use Python to do constants, but technically they're just like another variable. Whereas you have JavaScript, you might put const in there, but it's just a naming convention for Python. Okay, add a comment. So look, we've got 10 bullet points and 10 marks, so we literally want to be ticking these off as we go. Add a comment to identify the data type of the argument to the turtle mode subprogram on line 19. Well, the argument is this, and what is it? It's a string. Okay, it's a string, so use hashtag to save a string. That's the comment. That's just what it's asking for. Fix the name error on line 23. Okay, well, they misspelled height. So that's another mark. Literally tick these off as you go. Fix the attribute error on line 28. Now, you've got a PLS subset document that comes with this. Okay, so if we're using a variable, the turtle, to store this method here, turtle.turtle, that should be capital T. That should be a capital T. I'm pretty sure, yeah. Prepare the turtle, fix the attribute error. That creates the turtle, puts it into that variable, so we don't have to write this every single time. The turtle.penUp, so that literally lifts up the pen virtually. What's the next thing? Fix the type error on line 36. Fix the type error. So we've got the turtle dot pen down. Well, we don't have any number to put in there. It's literally a pen is either up or down. And it's a method that we just put brackets in. We don't always have to have a parameter in there. So that's the issue with that. Get rid of that. It's similar to penUp. Let's have a look. Fix the logic error that causes the vertical axis to be drawn too short on 48. Okay, well, line 48, they tell us in the question it should be 400 by 400. So it should be 400 there. We'll double check when we run this. Fix the logic area that causes the outside square to tilt left on the original 56. Well, it'll be tilting left if we don't have a right angle, so changing that to 90 should fix that. Add a line to set the size of the pen to the constant big on line 68. Let's have a look. Oh, okay, we have to add that line in ourselves. Fine. So the turtle, sorry, no space, equals pen size. Now a lot of this is in your subset document, PLS subset document, and you can literally put in there big, because we've got a constant called big with 8 in it. So we're doing well. Add a line to set the color of the pen to gold on 71. Fine. Okay, so the turtle dot, the method is pen color, American spelling, and then we put a string parameter in there. We just write gold. You can do basic colors using this, and then add a line to hide the turtle on 78. Let's have a look. there is an attribute called hide turtle. There's a method for it, so I'm just going to copy that. Hide turtle, and you always have to put these brackets in. Sorry, I just misspelled that. Let's see if it works. Got some issues here. Pen size is not defined. I've not used a method. Sorry. If you caught that and you're watching this, apologies. But this is why we run and debug, isn't it? It's literally just use the debugging tool. It says name error. So let's try again. This window's not very good, is it? That vertical line doesn't seem to be quite right. So let's just double check everything. We've definitely got a heading right, that's for sure. So just double check all of these things. Fix the logic error that causes the vertical axis to be too right. Did I miss that? Oh, I skipped over this one, didn't I? So we're moving over too far, so I literally just put a 0 in here. But so I'm rushing a little bit here, but I'm doing it as if you were doing this exam. So the only surefire way to check is literally just debug as you go. So now it's exactly what we expect. Okay, so I'm going through this as if you should when you're error checking your code. Methodically go through these lines. Because I'm rushing a little bit, I skipped this one entirely. And also I'd put an equals in. So I just need to be over here. Just need to be really careful to retrace my steps and make sure I'm not messing up. Good, let's have a look at the next question. A circle is cut out of a square of card. A program is needed to calculate the area of the excess card. The image shows the excess card in light grey. So let's look at the question. Okay, well, first of all, import math. It's a nice, easy one to start off with. I don't even need to look at the rest of the question to know that has to be in there. The program has, so how many points is this? 10 marks. We've got validation, so we expect this to be the output with these inputs. Do use those. Don't change any functionality, and let's have a go. So the length, okay, it's got some requirements that we need to make sure gets done, and it tells us in here what we need to do. So set the variable with a value of the correct data type for the area of the square. Well, the area is going to be, I mean, it tells you, right, it's not an integer because you can see the number itself. So a float. In your global variables, you can initialize these values, and they get updated later. But it is a float or a real number. Main program. Let's have a look. The main program side. These are all in the correct data type. Add a line to calculate the diameter of a circle. Well, it tells us what the diameter of a circle would be, so I can say diameter equals literally 2, and then use the asterisk for times radius, because we're given the radius of a circle. complete the selection statement, so conditional statement, to check that the circle will fit inside the square. So this is about our validation, isn't it? So what we want to do is, we've got a side value that we're going to get given by the person, and we can need to check if our diameter is greater than our side. Okay, if it's greater than our side, then immediately we can validate that input and say it's invalid. Now here's probably the more difficult part of this question. Make sure you indent, just to be checked, and you can do it from here. It tells you where it should be. Add a line to calculate the area of the outside square. So I'm going to say square camel case area equals side times side. That's the area of the square, isn't it? Add a line to calculate the area of a circle using exponential. So you need to use two asterisks here, not something times another thing. So that's what they're specifically asking you to do. So it's area of a circle. I mean, they tell you that the formula you should know from school. Circle area equals. Now we've got a math module. So math.pi method is how we can get the value of pi. And then r, radius, squared to the power of 2. If you want to make it neater, feel free to put brackets in there if you need to, but it will automatically do brackets, indices, division, multiplication, addition, subtraction. So math.pi times r squared, that's good. You need to make sure you do that, not just radius times radius. And then add a line to calculate the area of excess card. So the excess would be the difference in areas, won't it? So excess, I'm using camel case, where every subsequent letter is uppercase, and the first one's always lowercase, like the humps of a camel. Excess area equals, and just to avoid mistakes, I can literally copy and paste my variable names, because I've misspelt that already, haven't I? Because I'm rushing. Square area minus the circle area. Okay, let's just check. Enter a length. So length of side 12. Enter a radius 8. We expect invalid input. We get it. Enter a length 10. Enter 4. And that's what we get. So we're getting exactly the same as what's in the question. That way you can check that what you've done is what they expect in the question itself. Good. Well, we're halfway through. I mean, obviously the latter questions are harder, but we're first through the first half. A program converts a binary pattern to a positive denary integer. This is quite a useful program, actually. The user enters the binary pattern. Program loops continuously until the user inputs an empty pattern to stop the program. A multiplier doubles for each position from right to left to generate the place values, i.e. like a byte. When a 1 appears in the pattern, the place value is added to the running total. When a 0 appears, nothing is added to the running total. Makes sense, doesn't it? So 8 and 4 together is 12. And then this one is 9. No, it's got 8 bits. It's 1 byte. So we've got 128 plus 32 plus 8 plus 2. So let's look at what we're given. Right. So let's have a look through. the lines of code are mixed up. Ah, right, okay, they're mixed up. So we need to be careful here, because we don't want to be cutting things and then forgetting them to paste them in. This is why it's really important to make a copy of this file. And if you really, really want to, what you could do is, I don't know, you could just temporarily make a triple quoted string and stick everything in there, and you can delete that at the end so you can see what you were given at the beginning. Don't forget to delete that. So don't change the functionality, don't add any functionality, we just need to change things around until we get the desired result. So already we've got some issues with indentation, and we've got this subprogram which accepts a parameter. So what we probably want to be having here is, that is the main, that's going to be part of the main program, and it makes sense for us to, we've got loads of things indented. This is going to be the biggest clue here. So essentially that one, and that one are going to be inside the while loop. So let's start off with that. I'm going to cut this. I'm going to pop it in there, and I'm going to put these two, cut them, and I'm going to put them in here. Put that back over here. So let's just, I don't know if these are in the right order yet, but I know that the indented lines are going to be in a while loop. This is already going to just help me out here. So that we're asking binary equals input, enter a binary pattern. That makes sense, doesn't it? While the binary pattern is not an empty string, so that's the condition that this loop goes round on. It's a condition controlled loop after all, isn't it? Enter a binary pattern. Well, no, but this should be the last thing that we ask. So what we're doing first is saying binary equals binary loop binary, which is the name of our subprogram. So we're passing through this variable as an argument into this parameter and then checking. Then we're printing out what it is using layout.format. And the format is these placeholders are given as curly braces, which could come up in the exam. Obviously, you can see this is a real exam question. It's worth learning about layouts and formatting. So those curly braces here act as placeholders for variables, for these two variables precisely, binary and denary. Then, before we exit the while loop, we're asking and to enter another binary number, or to exit. So we're getting that before the next while loop goes round. So if they want to exit, it kind of makes sense. They can just not type anything, and then this will only run while the string is empty. So I'm pretty sure that these are correct. These should be fine. Just think of your decomposition. You're breaking up problems into smaller steps. Now let's tackle our subprogram. It kind of makes sense for you to check the indentations here again, because anything within a for loop is going to be indented. So what I'm going to try and do is put anything that's not indented. Oops, I'm going to have to be careful here. That's why you want to make a copy of this. I'm going to put anything that's not indented above the for loop. And typically we're getting ahead of ourselves. Let's put that over here. Just going to put anything that's not indented above the loop. just thinking of practical problem solving steps that you can take. So all of those indented items should be, when you've got a for loop and you put a carriage return, they're all indented, aren't they? So returning is like the last thing we do in a function, not a procedure. Procedures they don't return values, they might print them out or just do something. So this I'm going to put at the bottom for sure. That's definitely the last line. Returning a value is the last thing a subprogram will do. And now we've got all of these things plus that one. I want to get inside my loop, and I'll deal with the order in a second. Okay, so it kind of makes sense. We've got these local variables that are being initialized inside the subprogram. So total equals total. I'm happy with that. I mean, basically all of these are okay. They have to be above our loop, don't they? They have to be above our loop. What do we want? We probably want to just be careful about the order here. Total. We'll put digit. We'll put digit second, and then multiply by 1 at the end. So we've got our empty string value. Yeah, I'm happy with that. As long as they are basically above the for loop, we should be okay. Now we've got a for loop here for index in range length. That's fine. Now I'd expect this total to be updated once we've actually got a value. So that's definitely going to be underneath here. So let's have a look. P binary is our argument that's being sent through this parameter. So we've got that, the length of whatever they put in. We're working backwards here because the range function here, start, stop, step. And then we're saying, yeah, digit equals p binary index. That's fine because this will start off with the minus value, the start value, -1, the end. So that can stay where it is. Then we're saying value equals, which is it starts off being 0, equals multiplier times an integer of our digit. Fine. Then total equals total plus value, and then we're changing the multiplier by 2, which is the last thing we would expect to do in our for loop. So yeah, I'm happy with the order of these actually. I'm happy with the order of them. So let's just, first of all, let's just run it and see, is it actually working? So we've got the inputs here. Okay, it's working. Let's try again. 1 0 1 0 1 0 1 0, and we get 170. And if we put enter a binary, if we put empty, it should exit. Okay, so what I would say to you is, I used a bit of logical deduction here before sort of doing all of the sort of working out the actual logic of the algorithm. I just did a bit of logical deduction. If I've got indented values, then they're going to be part of this while loop or for loop. That if I usually initialize variables first before doing something, and you always return a value at the end of a subprogram. Similarly, you might print something out towards the end, and then we might ask them if they want to exit at the end of a process. So that way, if you're still not getting the intended answer, it would be just trying different permutations of these until you get the result, and showing permutations of these, which there wouldn't be that many different combinations you could have, and you'd probably stumble across it even if you didn't quite know what's happening here. So use a bit of logic to deduce where things might go, and I'm just going to get rid of that. I don't need that now. So I'm pretty much happy with that. I'm going to save that. Let's move on. A program uses a one. So again, these last two questions are going to be harder. Let's look at the Python file they give you. All right, so output file. So this is about writing to a file. A program uses a one-dimensional data structure. Fine. It's just a Python list. Two-dimensional data structures are nested. Okay. To record the number of kilograms of coffee used each day by a local cafe. Fine. The data needs to be saved to a file. Each line represents 1 week's worth of coffee consumption. I mean, having it as a two-dimensional data structure would probably be better because it'd be like a table. But anyway, it's not. It's just one list. Create a comma-separated value text file, also known as a record, and we're creating a comma-separated value text file. So we want to add all of this to a text file. Write lines to the file, including holding each 7 weights. Process all the weights in the data structure. So processing all the weights in a data structure, essentially saying use an iterative, a for loop to go over them. And it's also, this is where students make a lot of mistakes. They don't add comments, white space, or indentation. That's a really big thing here. Like, if you don't add those things, you're really going to be causing problems. And also, another mistake students make is they start writing your code here, where it should really be in the main program. Now, something's going to go in here, but this is the place where you'd have global variables. So usually what happens in here is we have to build up a string. We have to build up a string and then write it to the file. So I'm going to start with a variable called outline equals an empty string, because I want to start off as a global variable that anything in the program can use. And also, typically with these kind of these questions, we use a for each loop rather than for I in range, like the last question. We look at each item, and then we'll probably need to manually keep track of count. So I'm going to create a counter and initialize it with 1, and we'll see if that's what we need. But I can almost guarantee with these kind of questions that we need to have a counter that we keep track of ourselves, that we can potentially use for an index, where it might end up being a 0, or to keep track of how many times we've done something. Because we expect to have 7 lines here, and that can help us stop a process as well. Main program. So open the output file. So when you open in write mode, you are creating that file, which didn't exist before. So I can say this is just a variable. I can say the file equals open. Put the brackets in. I've got a constant already, which is a string. So I'm going to put output file, and I'm going to have that in write mode. If this wasn't here, then you would simply put that in, but it is there. So it's just checking to see if you know what a constant is. So this, if I run this, it should actually, even just in its current state, it should create a file for me. Look, there it is. It's created a file. So I know that that's working, and that's also in the PLS subset document. So that's an easy mark there. Process each item in the data structure. This is where we want to use a loop, a for loop. And also, just before I do that, I'm going to say, how do we always close, even after reading or writing or appending, we close. So dot close your file at the end. That's an easy mark. So even if you get to a question like this and you're stuck and you don't know what to do and you have a big panic, just methodically go through stuff, and even just check the PLS subset document, because if you couldn't remember how to read and write a document, you could at least get that and that from the PLS subset document, which is given to you in the exam, and that would give you a couple of marks. already just for free. So here we go. This is the most important part. Process each item in the data structure. So I'll just make a little bit of space for myself. I'm going to use a for each loop. So I'm going to just say for number, num, in, weights used. I'm literally copying exactly what's there to avoid spelling mistakes like I did in the last question. Colon, always end the statement with a colon, and then it will take you to the right indentation. So I've got an empty string, and this is what I need. This is why I put this here, because I usually 9 times out of 10 you have to build up a string. So I'm going to say outline equals outline, whatever's in there, plus our number. Now, if that is an actual number, which is a real number, a float, we want to change that to a string data type so that it concatenates to our empty string. Otherwise, we'll get an error. So that seems pretty easy. It seems too easy at the moment. Okay, so but we need to do a bit more. So we've got max per line. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9. So okay, so we're reading all these values, but for each line, they don't want more than 7 values in the file. And that matches what's in here. 1, 2, 3, 4, 5, 6, 7. So every time we get to the 7th one, we want to move on. Okay, so that's a condition. So if, I'm going to put in brackets here, if count does equal our max per line, which I've got as a constant, which is not going to change. If it does equal that, then I want to add a new line character, essentially, don't I? So what I want to do is take my outline and equals whatever I've got plus an invisible new line character. Don't use / backslash, because that's at the, when you press carriage return on a text document, that's what you get. You're putting a new line character in there. Then I want to write that, don't I? So the file, and this is also in the PLS, write our string outline. I want to write it. So far I think we're going okay. And then probably what I want to do is just say, once I've written that, I want to sort of change my count to be 1 again and change my outline to be blank. So I'm just going to say outline equals now a blank string, and count goes back to 1. Because I sort of go 1, 2, 3, 4, 5, 6, 7, and then I stop. And then I've got to have else here. So else, what am I doing? If I'm not at the end of the line, if I've not counted 7 things, and I'm resetting my variables, I'm simply just adding this comma and the next thing, and then updating the count. So I can say outline equals outline plus a string, comma. So I'm concatenating this comma here, and then I'm simply updating count. Oops. Updating count. I think this is it. So, well, the proof's in the pudding. Let's run it. Now, you're not going to see anything down here, but if I open up this file, did it create it? Hopefully it created it. I'll delete it and then try again. And then I'm going to make sure that I've done everything that I need to. Right. I think it might be an issue with this, actually. On a Windows machine, it would be fine, but I'm just going to try .text, because I'm on a Mac at the moment. So I'm just going to delete what was there. Weird, right, okay. So I'll put this back. Yeah, that's correct. Just going to pause and just check a few things. Yeah, I think when typed it earlier, I had count equals 1, and then it should be count equals count plus 1. I was just having some issues with my Mac and where the files were saving, but it should work now. So if the count is max per line, then we want to add a new line character. Else, outline equals outline plus strnum. And it will get written once we've got to our count. And if I run it and I look at the code, it's exactly as in the question. So we're all good. So let's carry on to the last question. Oh, got records here. Two-dimensional data structures. It's going to be a doozy, right? Or difficult, sorry. It's going to be difficult. In a board game, users build words from letter tiles. Fine, right? Each letter tile has a points value. There are 107 pairs here. By the way, it's not part of the Edexcel GCSE scope, but you would not see data structures like this used in the real world. Dictionaries would be used, key value pairs. It's fine. We'll make do with whatever we have, but just don't start using dictionaries if you haven't covered that. A program is required to check that each two-letter word placed on the board is valid. Each two-letter word with its points value is stored as a record in a two-dimensional list, word table. Fine, that's what we can see. Open the file or write a program to meet these requirements. Prompts for and accepts a two-letter word from the user, all the way from AA to ZZ, inclusive, accept uppercase and lowercase input. Fine, no other validation is required. Process creates a linear search to locate the word table. Stop when the word is located. The expected locations, we need to keep track of that. And the end of the list is reached after all words have been checked. Ensure that the search works for any length of word table. Fine, okay. When the user's word is located, inform the user of the word and the number of points it scores. When the expected location is passed, it's just the number, the next word and the number of points it scores. And again, we need to use comments, white space, and layout. And I actually don't think in that last question I added many comments, did I? Which is a problem. It's so easy to miss, isn't it? I mean, there are plenty of comments in here, but I would add, just add some comments. Okay, so for example, new character for next line, or new line, something like that. Conditional statement if items equals 7, something like that. Let's see, count. Just put some comments in there, and you can use a little bit of white space if you need to, just spread it out a little bit. You could put, for example, concatenation. All right, let's go back to our question 6. Okay, so we don't want to lose marks, do we? We've got quite a lot to do here. Write your code here under global variables and main program. So we've got very little scaffolding here. We've got to pretty much do the whole thing ourselves. Now, there's going to be a bunch of global variables that we want to put in here. We do not want to leave this blank. We definitely got to have a found flag. Got to have that. We also, if a word is passed, we'll start off with false until we get true. So we want to be checking to see if a word is passed, if the word is found or not. Let's keep track of our index, because if we're using a for each loop, we won't have an index to keep. If we had for I in range, we'd have our 0 potentially, but we're going to manually keep track of that. We can also say, before we get the word from the user, let's create an empty string to initialize that variable type, and then suggest the last word in the list. So I'm going to put suggest, and that will be a Python list. So those are all global variables that we want to add before we carry on with our main code. Okay, now we can get into our main code. And you might think, well, why do we need those global variables? Well, technically, all of this will work without it, but this is what you've got to get used to with, in terms of using the Edexcel's way of doing things. Okay, so we need an input from the user, don't we? So my words, we're going to replace that empty string with input. Start off nice and easy. Enter any 2 letters, colon, space. That's the best option there. All right. Enter any 2 letters. Fine. So that's going to be a pair of letters. And it says it doesn't matter if they enter lowercase or uppercase. So we do need it to be uppercase. Right. So we've got a method for that, haven't we? And I'm going to put comments in as I go. From user. All right. And then I'm going to say, because the comments should be able to help you, convert to uppercase. So I can say my word equals my word dot upper. This is in your PLS subset document. So you don't need to remember, you just need to know what this does and how to use it. You don't need to remember it. It's a method that we can use to make everything uppercase. So it doesn't matter if they typed uppercase or had the caps lock on or something else. Now we want to create a linear search algorithm. Stopping when found or passed. Okay, that's what they're looking for here. So linear search, we've got some conditions, haven't we, that we want to work with. So it's probably more appropriate to use a while loop rather than a for loop to just iterate over each thing. It's probably better that we have conditions. So I'll just start off with my parentheses, my brackets. What are my conditions? Well, what is the length of this word table? I don't want to go over it because I'll get index out of range errors. So whatever that structure is, I want to get the length of it, and that's going to be one thing. So I'm going to put different brackets here for each different thing, just to make it tidier. So as long as my index that I'm keeping track of is less than the length of my data structure that I'm traversing, then I can carry on. That makes sense, doesn't it? It makes common sense. Otherwise, I'll get errors where I'm looking for something that's beyond the scope of this data structure. And I'm going to, because I want all of these to be true before actually moving on. So all of these have to be true statements for the while loop to work. I want my found to be, well, what I can do here is use not found to make it true, and I can say not passed. That's one way of doing this, because all of these need to equate to true for my while loop to work through. So not found is true, not passed is true. So if the index is less than the length, it's true and true and true, and that way my while loop can carry on. Now, my conditional statement would be, if I'm looking for I want to find my word. So if I'm going to put brackets in here and a colon, whatever's going to be in there, found equals true, and not found would then become false, and this would stop working. So that kind of makes sense, doesn't it? I haven't put the logic in there yet. I'm going to deal with that in a minute. I'll do the hard bits. So, well, you know what? Let's do it. Let's just tackle it. So the data structure is word table. If word table, and then you square brackets for indexing, and because this is a two-dimensional data structure, I want to have two values here. So this one, AA2, is at index 0, because we count from 0. And then we've got a nice global variable that has got 0 in it that will get incremented every time we do this. In fact, I'll put that in now. If I don't have any of my conditions met, I can just say update index +1, right? So I'll update that. So index starts off with 0, that's fine. And then I want to literally look at the first thing inside this, which is the string. So this is always going to be, on the second pair of that, is always going to be 0. If my word table index 0, because it will start with 0, that will be 1, etc., go up. 0, 0, 1, 0, 2, 0 does equal my word that I've put in. If it does equal that, then found equals true. Okay. I mean, we've got quite a lot to do here, so we're just going to go through as methodically as we can. So the location of the user's word is if. So okay, trailing in search, stop when the word is located. That's fine. The expected location of the user's word is passed. The end of the list is reached. Okay, so what we can also say is else if word table index 0. I'm just going to put my colon in here. I'm going to put this pass bit in that equals true if we pass it. And if we do pass, suggest the next word and the number of points it scores. So I'm going to put the logic in just a second. If we get to this point, it's passed is true, and then we can say suggest and update that, equals whatever our one that we're looking at. Okay, so if word table index 0 is greater than my word, and yes, you can have strings greater than other strings, then past equals true, and then we can suggest the one that we are currently looking at on that index. And this way we can just put a little comment to say we keep looking. So like next highest row, and then we can say passed over. Oops. I'm just putting comments as I go because I don't want to forget. Passed over. And then here, found match. I'll put exact. So we're not quite done yet. This while loop is dealing with if we find it, if we pass it, and a suggestion. Now, if found, then we can do something. Okay, so what happens is we can just say is known and has a value. Then we can print out a statement, can't we? This is so much better to decompose your problems into steps. Let me just get rid of that. It's ugly, isn't it? And then I'm just going to put else if passed. We're also going to have some sort of print statement in here. We'll deal with what we're going to do there later. And then else. Always put the structure in first. So else would be target is greater than the last word in the list. So suggest last word, something to that effect. Okay, right, now let's work out what's in these print statements. It will be is known my word, and let's concatenate, is worth, and I'm not using F formatted strings in here. I usually do prefer them, but I'm just going to use this for now. Is worth, and then we want to sort of grab this and make sure it's changed into a string. Plus how points. Right. Then for past, does it give me any problems here? Yes, it's saying I need to have that. If past, else if past, my word is not in the list. Then else suggest so we suggest the last. I think we can, if the target is greater than the last word in the list, suggest the last word. Okay, so how do we get the last word? We can look at we can borrow this length of the word table. Let's just build it up from scratch. Okay, here we go. Suggest word table, and the square brackets, length of the word table -1, which will be the last item, because we're indexing from 0, aren't we? So that would be like the last item in the word table. It will be at the end. And then we can say print my word is not in the list. Use the same thing, but use a suggestion. Print use and then plus suggest, and then we can get index 0 from that because that's a list, plus how much it's worth. This is where we can get index 1 from it. Now that will be a number, so we need to convert that into a string. String plus, we're nearly done, points. That's a pretty difficult question. I think this will work, hopefully. Any 2 letters, BC. BC is not in the list. Okay. So we've got a little bit more to do, don't we? Because we want to say, we want to also suggest if the target is not in the list. So we've got, that's correct. And what we want to put in here, well, it's the same thing we've just done, isn't it? It's this. Let's try again. BC. Use BE worth 4 points. Let's put a little space in there. There we go. So I've searched for one that wasn't, and I deliberately used uppercase and lowercase characters to make sure that my upper method is working. And it's saying we didn't find what we were looking for, but use this one, which is worth 4 points. So I think we have it all working now. Plus we've got comments in. Phew, that was pretty tricky, but well done. Thanks for sticking with me. And if this is helpful, please let me know. Good luck.